You are treating a public API list like a free buffet, but in production engineering, it is actually a ticking time bomb. Engineers see lists of 80+ free AI services and assume they can plug them directly into automated pipelines. The reality is that these endpoints lack service-level agreements, have volatile rate limits, and introduce non-deterministic failure points that break systems silently. Relying on unverified free APIs for critical infrastructure is not a cost-saving measure. It is architectural suicide. Today, we connect this headline to the engineering trade-offs behind the hype and show you why treating these lists as permanent resources will eventually destroy your deployment reliability. The illusion of unlimited access starts with aggregated repositories like OmniRoot, which claim access to over 230 providers. The math reveals a hard ceiling that contradicts marketing promises. While theoretical capacity might suggest 10 billion tokens per month available for use, the actual recurring grants are capped at roughly 1.94 billion tokens across 530 models. This discrepancy exists because theoretical numbers assume non-stop usage without daily caps, which is a false premise for production planning. When you build an automated pipeline on these figures, you are designing for a world that does not exist. A single API can be capped at 3 messages every 2 hours or limit pro searches to just 3 per day. When your system hits these invisible walls, it does not pause gracefully. It fails silently and cascades errors into downstream systems until the entire workflow collapses. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This volatility is becoming more severe as major providers move flagship models behind paid walls. Tools like Windsurf and Tray have shifted toward strict quota-based billing or token tiers as of early 2026. This means a model that worked reliably yesterday can vanish overnight without warning, leaving your application with broken dependencies. The shift from free access to paid quotas is not just about pricing, it represents a fundamental change in how infrastructure stability is guaranteed. If you cannot verify the rate limit stability over time or assume all public endpoints are temporary by design, you have no business running them in production environments where uptime matters more than development speed. Beyond capacity and cost, there is a critical security blind spot that most engineers ignore when integrating these tools. The CISA Bulletin SB 26-19-4 highlights severe flaws in open-source components often found on these public lists, specifically the MaxKB vulnerability with the CVSS score of 8.8. This allows authenticated users to execute arbitrary system commands via malicious file imports if transport validation is not strictly enforced. Integrating third-party tools without rigorous checks turns your AI agent into a backdoor for attackers who can compromise your entire infrastructure through a single unvetted endpoint. 2 distinct CVE identifiers have been assigned to these risks, and while one vulnerability was fixed by upgrading specific software versions, the persistence of similar flaws in older systems suggests that 30 years of engineering debt is still plaguing modern tooling choices. The cost of ignoring these technical realities extends beyond code failures into human decision-making psychology. A study by Naito and Shirato shows that over 40% of users treat AI predictions as absolute authority even after repeated failures occur within their pipelines. In an automated system, this psychological bias leads to a 3.39 times increase in suboptimal decisions because engineers stop verifying the API output against ground truth data. The result is earnings reductions between 10 and 7% and up to 42.9% depending on the severity of the drift. This means that every time you trust a free endpoint without validation, you are statistically increasing your chances of making costly errors that could have been prevented with simple verification loops. The solution requires a fundamental shift in how we approach system design trade-offs. You must stop treating these lists as infrastructure and start building abstraction layers with fallback logic. The framework for production readiness is strict. If an API does not provide a service-level agreement, the answer is hard no. If rate limits are volatile or undocumented, you must wrap that dependency in a circuit breaker pattern to prevent cascading failures. Unverified sources require sandboxed execution where any external call is isolated from your core business logic. This approach prioritizes resilience over speed and ensures that when one endpoint fails, your system degrades gracefully rather than collapsing entirely. The choice for engineering leaders today is clear. Do you want the temporary speed of plugging in a free list immediately, or the long-term stability of building an abstraction layer? For production AI systems, the latter is not optional. It is mandatory to prevent architectural suicide. Your value as an engineer lies not just in knowing how to call an endpoint, but in understanding which endpoints will not break at 3 a.m. on a Sunday when traffic spikes unexpectedly. By recognizing that free API lists are non-deterministic failure points with no guarantees, you can build systems that survive the volatility of the open web and deliver reliable performance for your users. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.